AP Calculus, Day 58 notes. Our objective, understand and use the second fundamental theorem of calculus and functions defined by integrals. Okay, so for a review of the fundamental theorem of calculus, the integral of f of t dt from a to b is equal to the antiderivative, capital F of b minus capital F of a. So we used this earlier in Unit 6. And we've been using this terminology, function, first derivative, second derivative. When I undo the second derivative, take the antiderivative, I'm at the first derivative, take the antiderivative of the first derivative, I'm at the function. And we just started in Unit 6 and now Unit 7 using this capital F to go when I take the antiderivative of f of x. Well, if I kind of come over here, if that's f of x, well, I can take the derivative of that, and that is capital F prime of x. Hey, we see that's going to be similar. Obviously, there's some things we'll talk about, but that's going to be where we started with our original function, okay? And that's some of the stuff we're leading into with the second fundamental theorem of calculus. Let's go through and try these first couple problems. Okay, so given the functions f of t below, use capital F of x, antiderivative, have that be equal to the integral from 1 to x of f of t dt. Define not only capital F of x, but then f prime of x in terms of x. Okay, so let's go through and follow what we have to do. So when we go through, let's take the antiderivative. So this is going to be 4t squared over 2. And this is going to be minus t cubed over 3. And we're going to evaluate this from 1 to x. So 4 over 2 reduced to 2, and I just put a 1 here to show that as 1/3. So I put the x in first. That's our f of b minus f of a. Now we're going to simplify. So we find the function to be 2x squared minus 1/3 x squared minus 5/3. Now when I take the derivative of this, we get 2x squared becomes 4x. Negative 1/3 x cubed, the 3 times negative 1/3 is just negative 1 x squared, and then the constant becomes 0. And hopefully we're starting to notice, ooh, that's the same thing as up here, except if I had put the x in, 4x minus x squared. All right, let's look at the next one. Okay, so they're just asking us to find the integral of cosine of t, which is sine of t. Let's use the fundamental theorem of calculus and evaluate this at from 1 to x, which tells me I'm going to put in the upper interval first. So it's going to be sine of x minus sine of 1. Okay, and when I clean that up a little bit, and then I put in sine of 1 in radians, so we get the antiderivative is sine x minus 0.841. Now let's go and find the derivative. Derivative of sine is cosine, and the derivative of a constant is 0. And again, we should see, oh, if I just put that x in there, right? And this is leading to the second fundamental theorem of calculus. And again, these first two examples are just going to x. And we'll talk about how that differs from number 3 and 4. All right, let's take a peek at those two. Okay, so let's take the integral of t cubed dt from 1 to x squared. See, we get t to the 4th divided by 4, which is the same as 1/4 t to the 4th. Using the fundamental theorem of calculus, we're going to put in the values for the upper interval first, then the lower interval. So for our function, x squared to the 4th is x to the 8th, divided by 4 is the same as multiplying by 1/4, and then 1 to the 4th is 1. So our function is 1/4 x to the 8th, but they want to also know, hey, what's the derivative? So let's now take the derivative of this function. I'm going to start to try to see, hey, can we find any patterns here? So the derivative of this 8 times 1/4 is going to be 2. 2x to the 7th minus 1/4. Okay? So again, in our original function was t cubed, and we were, if I just substituted in, because again, when I take the antiderivative, then the derivative, I should end up back at the same place. But Doesn't always happen, and that's what the second fundamental theorem of calculus is going to teach us. But let's just say I put in x squared to t cubed. So if x squared was all cubed, I'd get x to the 6. And if I look, x to the 6 times what equals 2x to the 7th? Well, what's missing from what we did? Oh, this is 1. 1 times what? 1 times 2 is going to get me 2, and then x to the 6 is 2x. All right, let's just keep that in the back of our mind as we start to think of how does 2x relate to x squared. All right, let's try number 4. Okay, so the first thing we're going to do is just write it as the integral of 6t to the 1/2. So we're going to change square root of t from 1 to x squared. So what do? To take the antiderivative? Same thing we've always done. Undo the power rule. So add 1. So we get 3/2, and we divide by that, which is the same as multiplying by 2/3. And we're going to evaluate this from 1 to x squared. Now, hopefully we see 2 times 6 is 12, divided by 3 is 4. So we can just know that we're 4t to the 3/2. All right, let's do some math here. And then just remember, when you raise something to the 3/2 power, that's taking the square root first. So the square root of x squared is x, then raising it to the 3rd power. So our antiderivative here is going to, and that's just the x squared is being raised to that power. So that's 4x cubed. 1 cubed is 1, and then square root of 1 is 1. So 4x cubed minus 4. Okay, and let's take the derivative of this. So the derivative equals 3 times 4, because it's power rule, 12x squared. Okay, and now let's look at, well, wait a second, how did that end up looking what we just did? Okay, so let's do the same thing we did over here. So we started with 6 square root of t. What if I had put in x squared here? Okay, so that's going to end up being 6x. But something's missing, and from how I get to 12x squared, because that was the derivative after I did the antiderivative. Again, if I do the antiderivative and then I take the derivative, I should end up where I started, but something's missing again. Well, 6 times what is 12? Hey, that's 2. X times what is x squared? That's x. Hey, 2x, that was the same. We said that's what we're trying to figure out. How does that relate to x squared? And that's what we're going to learn on the next page.